Hello class, in this lesson we're going to use trigonometry to find unknown angle measurements in right triangles. Once again, you have to know SOHCAHTOA. It's going to be very, very useful throughout this chapter. So first, as a warm-up, I'd like you to try this problem. I want to figure out how tall this tree is that Dan is looking at. So try that, and then I'll show you my solution. So here's how I labeled my diagram. And so which ratio are we going to use here? We're looking for the opposite, and we have the adjacent, so we should use tangent. All right, so tangent of 35 degrees, and the opposite over adjacent, that's x over 40. So we use the cross product. And we plug it in our calculator. Remember, make sure your calculator is in degree mode when you first turn it on. Press mode, down, down, right, enter, put it in degree mode. So 40 times tangent of 35 gives us about 28. All right, and it says, how tall is the tree? Let's round to the nearest meter. So we know that Dan is 2 meters tall. We know this distance is about 28. So how tall is the tree? The tree is about 30 meters tall. Now, in the same diagram, we have Dan looking at another tree that's taller. And he says it's at least 50 meters tall. He wants to figure out what is his angle of elevation to the top of that larger tree. So let's see if we can solve that using trigonometry. So here we have the picture, and we're assuming this tree is 50 meters tall. So let's see, we have, looking over on the left-hand side now, so this is adjacent, hypotenuse, opposite. And what's this distance here? We know the entire tree is 50 meters tall, and this distance to Dan's eyesight is 2 meters. So this distance must be 50 minus 2, 48 meters. So this would be tangent, once again, opposite over adjacent. And tangent of y, our angle, is going to be opposite over adjacent, so that's going to be 48 over 40. And we can simplify here, and we get tangent of y is 1.2, or 6 over 5. So that means y must be what? How do we figure out what y is? We have tangent of some angle measurement is 1.2. But we have to figure out a way to get rid of this tangent here. And we don't have a method for doing that yet. Right? If we were adding, we could subtract. If we were multiplying, we could divide. But in this case, we don't have something to undo tangent with yet. So that's what we're going to learn about in this lesson. So we're going to come back to this example in a little bit. So keep it in mind. And yes, we will solve it. So don't worry. So in order to undo the three trigonometric ratios, we use arc functions. And we use the word arc because it refers to how we measure angles and arcs of circles. So they're related to each other. And let's see how we can use them. So first, write out the ratios for angle C. Try that now, and then I'll show you the answers. So here are the three ratios. And for angle A, what would the ratios be? So we're looking up here. And here they are. So now, I'm going to show you statements involving the arc sine, arc cosine, and arc tangent. And see if you can figure out, based on the descriptions, how they relate to what we have up here and what they mean. So look at what we have in this first row. See how that's related to what we have down here. Well, hopefully, you noticed that it has something to do with figuring out the measure of the angle. So now we're kind of working backwards. So the meaning of this, the meaning of arc sine of this ratio, means that we're finding the measure of an angle that has a sine ratio that's equal to AB over AC. And we can do the same with the other ratios. In your own words, what does arc cosine of BC over AC equal to the measure of angle C? What does that mean in your own words? This gives us an angle measurement that has a cosine ratio to what we input. That's BC over AC. And finally, for arc tangent, Same idea. Angle C is going to have a tangent ratio that's AB over BC. Now on the calculator, usually they don't write out arc sine, arc cosine, arc tangent. They use the inverse notation. So this is, it looks like an exponent that's -1, but it's really not. This -1 just means inverse. So this is inverse sine, inverse cosine, inverse tangent. I'll show you how to do this in the calculator in a moment. But let's go back to the problem at hand. We want to figure out what is that angle of elevation. So looking here, we got this far and we got stuck. So now to undo tangents, to get rid of that tangent, we're going to apply arc tangent to both sides of this equation, or inverse tangent, whatever you want to call it. They're the same thing. So if we apply that to both sides, look what happens. When we're dealing with acute angles, we can do this. And since we have right triangles, those are acute angles. When we have acute angles, these undo each other, tangent and inverse tangent. So now we're just left with y equals this number. And how did I get this? That's from the calculator. So to do the inverse trigonometric functions here, you press second, and then the button for it. So there we have it, inverse tangent. And you can put 6 over 5 or 1.2 in there, and it outputs our angle measurement. So if we round to the nearest degree, we have about 50 degrees. It's a very similar process for the other inverse functions. So I'd like you to try the same idea here. Here we have 3 examples. I'd like you to try to find the measure of each angle to the nearest degree. So try that, and then I'll show you my solutions. So in the first one, hopefully you saw that we're using cosine, adjacent over hypotenuse. So to undo that, we're going to apply inverse cosine to both sides of this equation. Put that in the calculator, and you get about 49 degrees. For part B, we're using the opposite in hypotenuse. So it's going to be sine. Apply inverse sine to both sides, and we get about 72 degrees. And finally, in part C, we're using the opposite and adjacent, so it's going to be tangent. Apply inverse tangent to both sides, and we get about 26 degrees. Here's an example where we have all 3 sides. Look, you try to figure out the measure of angle D, and then I'll show you different ways we could solve this problem. So what we have here is we have a lot of information, and there's actually 3 different ways we could solve this. Because we have all 3 sides, we could use any of the 3 trigonometric ratios. So if you did it with sine, you would have written this equation. Cosine, you use this one. And tangent, you'd use this equation. And no matter which one you use, after you apply the correct inverse trigonometric function, you end up with about 53 degrees. It's very important that we can draw diagrams correctly. So based on this problem, I'd like you to first draw a picture of the problem, and then find the vertical distance from the ground to the point where the top of the ladder touches the wall. So try that, and then I'll show you my solution. So here is my diagram. Here the diagonal is the ladder. And I used theta for my angle measurement, but we're not going to need that yet. We're just talking about these distances. And we have 2 of them. So we can use Pythagorean theorem to figure out that, the typo there. Pythagorean theorem to figure out that height. So we evaluate this and then solve it. And it doesn't say to write anything in simplest form, so you can just put that in the calculator, and we get about 14 feet. So now we want to figure out that angle of elevation, angle formed by the ladder and the ground. So see if we can solve that, and then I'll show you my solution. So here we have adjacent, opposite, hypotenuse. And the opposite is a number that we rounded, so we really shouldn't use it. So we should really use adjacent and hypotenuse. So let's use cosine. So cosine of theta is 7/16. Apply inverse cosine to both sides. And we end up with about 64 degrees. And finally, here's one about a mountain. First, draw a picture of the situation, and then we'll look at how we want to solve it. Now, keep in mind, it's called Mile High Mountain. So what's the altitude of the mountain? 1 mile. So here's my drawing. Here's the campsite down here, 3 miles from the base, and 1 mile in height. So now you want to figure out what is the angle of depression. So the angle of depression, remember, is if we're looking down from a horizontal. So we're talking about this angle up here. Now that's not inside our triangle, but what angle do we know is congruent to that one? We know that we have alternate interior angles that are congruent because we have 2 horizontals. So that's the same as this angle. These both measure theta. So how do we figure out that angle? Well, we have opposite and adjacent, so we should use tangent. So tangent of theta is 1/3. Apply inverse tangent. It should be a superscript. And we get about 18 degrees. And I made another typo, sorry. In this lesson, we learned how to find unknown angle measurements in right triangles by using trigonometry. Thank you for watching this video.